Welcome back. Today we're talking about antiderivatives. So antiderivatives would be the opposite of a derivative. So basically they're going to give us a derivative and we have to find the original equation. So we're kind of going backwards. So this would be the notation. I have y equals, I have this little symbol here, that little symbol there is the integral sign, and I have f of x dx. So f of x, again, would be the derivative, and when I do the integration, which is another way of saying antiderivative, when I do the integration of f of x dx, I'm going to end up with capital F of x, which means that's the original function. So lowercase f of x dx is the derivative, and uppercase f of x is the actual function that I started with. Dx tells me that it's with respect to x. So that means I'm taking the derivative with respect to x. So x is the variable that I'm taking the derivative of. When we start talking about making a substitution and a whole bunch of other stuff, that's going to come into play. I think you're probably going to do that next year, but who knows? So anyways, we're going to be talking about indefinite integrals, which means right now we have to have a c. Because remember, when I take the derivative of a function, I take the derivative of a constant. When I take a derivative of that constant, it goes away. So if I'm going back the other direction, I don't know what that constant was because that constant is gone. That constant could be 0, it could be 5, it could be 10 million for all I know. But I don't know what it is. So instead, I'm going to put a c there, and that c is going to represent the constant that could be there. And I'm always going to do that in an indefinite integral. So here's our first equation. We have the integral of 5x cubed plus 2 cosine x dx. So I'm going to take the antiderivative. So when you take the antiderivative, you write down the function. So I have 5 as I write down the coefficient, I should say. So I'm going to write down the coefficient of 5. I'm going to add 1 to the exponent this time. So since it was x to the third, I'm going to add 1 to that to give me x to the fourth. And then I'm going to divide by the index, or by the exponent. So since it was an x to the fourth up here, I'm going to divide by a 4 down there. And then I'm going to take the 2, which is my constant, and take the antiderivative of cosine. The antiderivative of cosine is sine of x, and then I'm going to put my plus c. If I could simplify the fraction of 5x to the fourth over 4, I would. In this case, I can't. So my answer is just going to be 5x to the fourth over 4 plus 2 sine x plus c. Next one. So this time I have the integral of 8t cubed minus the square root of 6t, or 6 times the square root of t, plus t to the 1 over 3. Now, what I would do first is simplify this. So I would rewrite this 6 times the square root of t as 6t to the 1/2, because it's going to be easier if I have it in exponential form. And the 1 over t cubed will be easier if I write it as t to the negative 3. So now I'm going to take the antiderivative. So I write down the coefficient, which is 8. I add 1 to this exponent of 3 to get 4. So I have 8t to the fourth over 4. And then I'm going to have the minus, because there's a minus there. And I have 6t. I add 1 to the 1/2. If I add 1 to 1/2, I get 3 halves. So I have 6t to the 3 halves over 3 halves. And then if I have t to the negative 3, that would be, if I add 1 to that, I would have t to the negative 2, and then that's going to be over negative 2, and then plus c. And then from there, I would simplify. So 8 divided by 4 is just 2t to the fourth. And then I have 6 divided by 2/3. So if I 6 over 1 divided by 2 over 3, that means, or sorry, 3 over 2, it means I'm going to flip it and give me 6 over 1 times 2 over 3, which would be 12 over 3, which reduces to 4. So that gives me 4t to the 3 halves, and then I'm going to, oh, I forgot the negative there. I would have negative 2 down here, negative 2 and 1 over t squared plus c. And that would be the answer to that one. Next one. Now, the first thing you want to do, again, is you want to simplify. So I'm going to multiply out x squared minus 1. So if I multiply out x squared minus 1, I would have x to the fourth minus 2x squared plus 1 over x to the second. And then I'm going to divide. So if I put x to the fourth over x squared, I get x squared. If I put 2x squared over x squared, I get 2. And if I put 1 over x squared, I'm going to have x to the negative 2. From there, I'm going to take the antiderivative. So I add 1 to the exponent. If I add 1 to the x squared, I'm going to end up with x cubed over 3. If I add 1 here, I would have negative 2x over 1, so it's just negative 2x. And then if I add 1 to negative 2, I have negative 1. So I have plus x to the negative 1 over negative 1, and then, of course, plus c. Then I simplify. Usually, you'll rewrite it as 1/3 x to the third, but sometimes I've also seen it as x to the third over 3, so it pretty much doesn't matter. And then minus 2x, and then minus 1 over x plus c. You do always simplify the negative exponents so that they become a positive exponent by putting them in the denominator. Next one. I end up with the antiderivative, or the integral, of 3x to the fourth minus 5x squared plus x. That dx sort of got stuck in the middle there, but we really didn't mean to. So again, I'm going to add 1 to the exponent. So that would give me 3x to the fifth over 5 minus 5x to the third over 3 plus x to the second over 2 plus c. So I end up with 3x, 3/5 x to the fifth minus 5/3 x to the third plus 1/2 x to the second plus c. And that is how we do antiderivatives, because that is all we have. So now try your problems on the Google form, and I'll see you in class next time. And of course, we'll practice them some more. Good night.